So this unit is all about kinetics, the kinetics of chemical reactions. So that word kinetics, if we think of like kinetic energy, for example, kinetics has to do with motion. So in this unit, we're all talking about the motion, the speed of molecules, how they interact, the speed at which they react, how fast they react, what different factors will affect how they react, how can we quantify that, how can we graph it, how can we draw mechanisms. We're going to learn a ton of stuff about reaction kinetics. But first, this video is all about review of reaction rate. So I'm going to reference a lab that we did in CP chemistry where we took vinegar, which is basically acetic acid, CH3COOH, and we added vinegar to Alka-Seltzer, which has the chemical formula NaHCO3, sodium bicarbonate. And if you remember, we added these into a film canister, boom, boom, into a film canister, and then we took a lid and we put a lid over the top. And what happened was this reaction produces water, ionic salt, sodium acetate, NaCH3COO, sodium acetate, but most importantly produces CO2 gas, carbon dioxide. And so that reaction in here started forming a bunch of bubbles, 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 and the pressure got so large that boom, this lid blew off. And in CP we measured the time that it took for, once we added the mixtures together, to blow off the lid. And we said that that was a direct relationship with the rate of the reaction rate. Well, what does that actually mean? Well, if we think about the word rate kind of means speed. Okay? So a reaction rate, when you measure the rate of a reaction, you're measuring how fast, the speed of the reaction. What do we mean by the speed of the reaction? Well, we can measure, this is a definition you need to know, make a flashcard for it. Reaction rate, which you'll see abbreviated as RXN frequently, is essentially how fast or slow a reaction occurs. But now in AP, we're going to start getting more quantitative and measuring. How do we actually measure the rate of the reaction with numbers and units? Well, what we're going to be measuring is we're going to be measuring a change. Remember, delta means change. A change in the concentration of either the products that are being made or the reactants that are being consumed over time. So when we quantify the rate of a reaction, what we're really measuring is a change in the concentration of the products or reactants. And so we know that over time, the amount of products in a reaction is going to increase because they're getting made, whereas the amount of reactants are decreasing, the concentration, because they're getting used up. So we think back to this reaction here. Initially, we had, some vinegar, okay, maybe like 100 milliliters. And we had some Alka-Seltzer, maybe like 10 grams. And we had 0 grams of carbon dioxide. Once we mixed them together, these guys started reacting. They started mixing and combining. As they combined, they formed CO2. So the amount of CO2 went from 0 grams to maybe 2 grams of CO2. Again, I'm just making up these numbers, but the idea is the amount of products over time increases. Concentration of products increases. At the same time, since we're using up vinegar and Alka-Seltzer, you're no longer going to have 100 milliliters of vinegar or 10 grams of Alka-Seltzer. The concentration of reactants is going to decrease. And we can measure that, we can quantify it, and that's what we're going to do over the course of this unit. We also learned a few things about what can affect, factors that can affect reaction rate. One was temperature. We said that if we increase the temperature of a solution, the reaction rate will increase. And we'll talk about that more thoroughly, why that occurs, but if you remember it, as molecules have a higher temperature, they have more kinetic energy, which means they're moving faster, which means there are more collisions, and more collisions means a higher rate. We also learned that we can change the surface area of some substances. So if we increase the surface area, so for example, we go from a whole tablet to a crushed up tablet, lots of little pieces. Just imagine taking a sugar cube, here's like your sugar cube, and here's that same sugar cube crushed up into a lot of pieces. This has more surface area, and if you have more surface area, you're going to have a greater rate of a reaction. Because again, there's more places for molecules to get in here and interact and collide, versus here, there's only the outside. More surface area means greater rate. We also learned that you can change the concentration. And this is very simple. The idea is if you have a greater concentration of reactants, you're going to have a faster reaction rate. So just think about it simply. If you had that same reaction of Alka-Seltzer plus vinegar, imagine instead of having to make carbon dioxide, among other things, water and sodium acetate, imagine you, instead of having one tablet, you had 4 tablets. The concentration of Alka-Seltzer increased because you have more of it, so there's going to be more of it to react, which means there's going to be more collisions, which means the rate is going to increase. So to refresh your memory on kinetics, to get back in the swing of things for semester 2, what you need to know is what is the definition of reaction rate, which is how fast or slow a reaction occurs. How do we quantify it as a change in concentration of products or reactants over time? That's a definition you need to know for a flashcard. And you need to know what are the 3 factors that we've learned that can affect the rate of a reaction, and how do they affect it? Are they directly related? Are they indirectly? And what are they doing to the number of collisions?